The original AI researchers were very interested in games because they were extremely complex. Huge numbers of possible positions in games were available. Yet they're simple in a certain way. They're simple in that the moves are well-defined, the goals are well-defined, and so you don't have to solve everything all at once.
With chess in particular, and the work on Deep Blue at IBM, what became apparent, what computers could do on a problem like that, was bring a massive amount of compute resource to do deeper searches, to investigate more options of moves in chess that than was previously possible. Watson defeating Jeopardy, so this was another crossover point in sort of the development of AI and cognitive computing. The questions that IBM was able to answer with Jeopardy were questions that weren't simply looking up in a database and finding the answer somewhere. Rather, it required information retrieval over lots of different information resources, and then the combining of these together using machine learning that could arrive at answers that went beyond what was simply written somewhere.
Now our technology is so much better and so much more advanced that we're really ready to move on and to tackle much more challenging problems that have this kind of ill-defined or kind of messy nature.
Every industry, from oil and gas to healthcare to media and entertainment to retail, are just being swamped by a tsunami of unstructured data. That can be, multimedia, it can be images, it can be video, it can be text. And it's really the ability to understand that data that is becoming critical.
One of the most valuable applications of cognitive computing is in the health domain. Medical providers, physicians, nurses, assistants face enormous challenges leveraging all of the available information that's out there. The medical literature increases by about 700,000 articles every year, and there's already millions of journal articles out there. And today's imaging technologies produce very rich amounts of information. In fact, a particular scan might have 5,000 images in it. You combine the image analysis with natural language understanding and text analysis, leveraging the medical literature, leveraging the patient's medical history, the physician has got a lot more information and knowledge at their disposal to help them make the best diagnosis possible.
Clearly, there's this intersection of what the computer can do and what people are able to do that gives you something that's better than each of them individually. What is going to be truly interesting is to see what is the best way for them to have really symbiotic type of interaction, taking advantage of each other's strengths to collectively solve a problem.
Watson, it looks at another aspect of intelligence and a much more difficult aspect of intelligence, that is language. You have to be able to interpret the questions and come up with the right answers, no matter what the topic. So I think the ideal scenario for AI in the modern world is not to try and develop a system that completely autonomously handles every aspect of a problem, but have a collaboration between machines doing what they do best and people doing what they do best. And I can imagine that combination will do better than either one by themselves. We're constantly here looking for what's the next grand challenge problem we can take on that's not just around the corner or a year away, but it's going to take a multi-year effort, and when we get there, we'll have something that's valuable for the world.
What does AI have in store for us in the future?
My crystal ball is a little cloudy, so I don't know if I have a prediction that I would bet money on. What I do know is what we have seen is the way AI has progressed. It starts fairly slowly, but then it gains steam exponentially. One good example is DeepMind put the system together that won in the game of Go. It's a 2,500-year-old game, which won against a human opponent. But what's most amazing is, while the first system was able to outdo 2,500 years of human history in the game, the second generation of that system was able to outplay the first generation of the system in less than 1 year. And it only took about 40 hours of training for it to be able to achieve that level of proficiency in that game. And it won 100 games out of 100. So what we do know is the pace of which this technology is accelerating is just breathtaking, and it's not something we can predict very well. So if it was one prediction I were to make, it's going to get faster, it's going to get better, it's going to get cheaper, and it is going to happen very, very rapidly, within a very short period of time.
It's going to be an interesting world. It's going to evolve very rapidly because these technologies not only can perform tasks that we've never seen automated before, but learn as they do them and continue to improve. So what we'll see is we'll deploy systems, and every year they'll get incrementally better at the tasks they're trying to do. So we won't have to drive our own cars anymore. Hopefully we won't have to put away our own dishes. There'll be a lot of simple things in our lives that become automated and become eliminated from our daily task list. It's a revolution that we've been through before. The first washing machines, the first dishwashers, etc. All these things have helped us to enriched our lives and simplified the way we live and increased our comfort. And I think we'll see many more such evolutions as we watch the AI world unfold.
Particularly in healthcare, I think we'll see faster recovery times. We'll see better patient outcomes. We'll see people spending less money and time in hospitals and in various care centers. AI has been game-changing for healthcare. There's so much information that we can take out of a particular system and apply it to another. We can build all sorts of models that have been, that can be hugely beneficial to long-term care. So that's something that I'm very excited about, and seeing that evolve.
Looking into the crystal ball, I'm always apprehensive to make long-term predictions, but my hope is that we are able to indeed deploy these collaborative robotic systems, including self-driving cars, to make people's lives better. That's the idea, is to use AI and robotics technology to improve the quality of life for the whole spectrum of society. So I would be looking forward to a future in which AI plays a central role in freeing us from the dull, the mundane, the dirty, the dangerous jobs, and hopefully providing us with more time to spend with our families, better health, potentially, better health care through data analysis. And so I think if I envision the future that I hope will come to pass in a number of years, we'll be really leveraging these technologies to make our lives better and to free ourselves from dull, dirty, dangerous work.
In a world of dramatic digital transformation, companies are looking to AI to really help them shape the future of work. AI can predict and inform future outcomes. It enables people to do higher value work and businesses to imagine new models. It can automate decisions, processes, experiences, but AI is not magic. The truth is, there is no AI without IA, or information architecture. But many organizations can't start because 80% of their data is locked in silos and not business ready. So how do you turn your aspirations into outcomes? Through a prescriptive set of steps we call the ladder to AI. And it starts with modernizing all of your data on a single platform that runs on any cloud. Then, on the ladder itself, there are 4 steps. First, collect the data, to make it simple and accessible. Really think about the models you need to train. Second, organize your data to create a business-ready analytics foundation for those AI models. Third, analyze your data, both with trust and transparency, because there's no use in applying and scaling AI if you can't explain the outcome, detect bias, or prove its accuracy. Fourth, once you can really trust your data and the AI that you deploy, then you can realize its full value inside of the apps and processes that control your everyday work. In other words, the last step is infuse, where you begin to operationalize AI throughout your entire business. We help thousands of enterprises put AI to work by unlocking the value of their data in this AI and multi-cloud world, by delivering the right set of skills for their people, and by building trust and transparency into AI. That's the ladder to AI in a nutshell. Let's start climbing.
What advice would you give to someone who wants to learn AI or perhaps even get into a career in AI?
So I believe artificial intelligence is going to permeate every sphere of human endeavor. So the first thing I would say is I would congratulate the person who've chosen to study and apply AI as having made the right choice. The second part I would say is because the technology is moving so fast, because we have not yet discovered what we're gonna discover, I think it's really important to keep an open mind. It's important to keep an open mind and not get too attached to any particular technology, any particular technique, any particular implementation, but to really think forward and think outside of the box and think about, think about the art of the possible, think about what may come. And the number one advice I would give is apply what you learn. Don't make it academic, make it practical.
The first thing I would say is take a look at a great Coursera course like this one and grasp the basics of AI, get a fundamental lay of the land and understand what is involved in various types of AI systems, and perhaps find the niche that you're most interested in. And then, of course, look at academic programs that can help you to learn more about that specific area. And for students who are coming up through high school, for example, I would say definitely spend time focusing on math and science. Certainly all disciplines are valuable, but your knowledge of mathematics and science will certainly pay off when you're working on AI systems, because there are tons of opportunities and you'll need mathematics to really fully understand how the AI systems operate. So take your mathematics and your science seriously, and then look at Coursera, and then beyond to other educational programs that can give you the basis you need to really jump into the industry.
The field of AI has changed a lot in the last 5 years. You no longer require a PhD in some kind of advanced mathematics or know some obscure programming language. You just have to know how to use the software APIs and understand the problem. For example, you can use Watson, and you just have to understand the problem and understand how the API works. But you still require some advanced knowledge if you would like to build your own algorithm.
So artificial intelligence, machine learning, this is a very important field. It is the future of technology because it essentially opens up this whole new world of interaction with computers. A world that so far we barely even knew existed. It enables us to interact with computers in an implicit way. But what I would say is that while machine learning technology is important, it's not something that you can learn in isolation. machine learning technology is not its own standalone subject. It's another algorithm in the toolbox of a plethora of algorithms that programmers will use in their applications, albeit a much more intelligent or a much more powerful algorithm than most, but still, it's another algorithm. So before you learn machine learning technology, it's very important to understand the actual programming and the technology that goes behind machine learning technology, specifically because machine learning actually requires this kind of next generation of programming, hardware acceleration, and so much more that regular programming and regular algorithms don't necessarily require. So I would really recommend making sure that, first of all, you are passionate about technology itself. If you are, continue. Learn about programming, learn about coding, learn how to actually speak the computer's language, learn about the computational thinking behind code, and then go ahead and learn about machine learning from the very, very basics. Start off with an API like IBM Watson to help you get an idea of what it's capable of, and then move on to more advanced custom techniques and the math behind them.
So AI is a fascinating field, but it's built on a huge number of foundational domains or foundational fields of study. So you really need to know your mathematics, you really need to know your probability theory and statistics, your optimization, and you have to be able to program. You have to be able to take advantage of the tools that are out there to train these networks and understand how they work. So AI is a really broad field that requires a lot of specialists and a lot of specialization in different areas. So one of the best things you can do is to get started quickly. Start playing with some simple tasks. Try to identify digits or try to find cats on internet pictures, right? Things like this. These are wonderful challenges that can get you going and understanding what you need to learn about that field.
Getting into AI now is like getting into anything to do with internet, 20, 30 years ago. It's kind of the renaissance of software right now. It's possible now. It wasn't possible 10 years ago. We have the computing technology, we have the computing power, we have the knowledge, and this is a field that will only grow. So I think you need to get in yesterday.
My latest poll of top cities for AI, which is primarily myself just looking at what's coming through my own inbox in terms of opportunities, it's fairly widespread, actually. There are a lot of opportunities in a lot of different places. So there's, of course, the San Francisco Bay Area, which continues to be a hotbed for startups in AI and robotics, and I think will continue to develop. There's Boston in the United States, which also has a large number of startups. There's Seattle. And then here in Canada, we've been doing a great job in both Toronto and Montreal of actually developing quite a robust and thriving AI ecosystem that I think is going to also continue to develop and grow. So I think we're quite excited about that. And then farther afield, there are a number of locations in Europe, Asia, some opportunities in China, certainly, China and India as well, absolutely. So lots of, if you're located somewhere next to a major city center, I think in any of these areas, you're well positioned to launch your AI career.
Toronto is exploding. It's been amazing to watch and be a part of. We have Geoffrey Hinton, obviously, one of the 3 pillars of the Turing Award for the major contributions in deep learning, and the whole Vector Institute and ecosystem has come up around the wonderful progress that came out of the University of Toronto over the last few decades. And so what we're seeing is wonderful incubators and startups in the area, investing heavily in AI technology and capabilities. We're seeing large companies bringing in research labs and putting those right next to the university. And we're seeing, a wonderful amount of funding coming in for research, specifically in AI in Toronto. So I think we're competitive with any of the best places to learn and work on AI in the world.
I think Canada is actually doing very well. We've done an excellent job overall in terms of centralizing some really fantastic AI talent. So in Toronto and Montreal in particular, and also in Vancouver, but Vancouver, Edmonton, a number of different cities in Canada have really become very strong AI centers. And they continue to grow. And we're attracting a lot of great AI talent. And I believe that will just continue. So Canada is shaping up to be a great place to come and do AI research and work in AI.
So can you talk about advice for people who want to get into AI, especially the teenagers like you or other students who are fascinated by technology and AI?
So really what I believe, first of all, is, I've seen a lot of misconceptions about AI, really, wherever I go. Whenever people ask me, how can I get into the field of machine learning or AI, there are lots of misconceptions. They feel like, machine learning is its own independent, isolated subject, and if I learn it, I can go ahead and implement machine learning algorithms or these things. But really, if you think about it, machine learning is just another algorithm in the toolbox of algorithms when it comes to programming, albeit, in some cases, it can be much more powerful than other algorithms. And on a very fundamental level, it is another algorithm. So before you get into the field of machine learning, before you get into the field of AI, it's very important that you understand how to code. And since machine learning is a relatively complex technology, having a very, very advanced knowledge of how computers work, how exactly coding works, even sometimes the backends behind compilers really, really does help you on your journey of learning how to code machine learning algorithms. And the reason I say this is because machine learning isn't just a regular algorithm that you implement. It's not just pathfinding or search or something of that sort. It's special because it requires intense hardware acceleration. It requires you to understand at least a little bit of the calculus that goes behind backpropagation. All of this is necessary to understand the fundamental workings of machine learning and AI. So really, to summarize, what I'd recommend is, first of all, you should be passionate about technology itself. If you're not passionate about technology, machine learning technology, it really isn't something that you should go and work towards. And then from there, once you know that you're passionate about it, you want to do it, then go ahead and start off by learning concepts in the field of technology. Learn how to code in languages like Python, Julia is a new language, Swift because of the new Swift for TensorFlow project. And then from there, go ahead and learn a little bit at least of the actual math behind neural networks. I remember when I stumbled upon Watson, that was the first time I ever heard of machine learning. And when I went from Watson to custom neural networks, the first thing I did is I actually drew a small neural network on paper and did the backpropagation manually to understand, how exactly weights are updated, how the loss values work, all these sorts of things. And once you have that fundamental understanding, then you go ahead to implement those neural networks from scratch in your languages. And then once you have a good idea of how it works, once you practice, once you learn by example, then you're finally ready to go ahead and use different libraries, use different toolkits to enable you to rapidly prototype and build applications in the field of machine learning. So that's a very, very high-level viewpoint that I'd say to get into machine learning. But of course, there are better ways and more intuitive ways to get into machine learning as well. Like, for example, Watson, if you take a look at how it provides its APIs on the cloud, you don't need to understand any of the workings behind machine learning to use Watson, and at the same time, you can still leverage all those powerful capabilities. The language translator lets you use practically state-of-the-art neural machine translation techniques and even train your own models without having to understand a single clue behind what goes behind the models. And so being able to start off with a toolkit like Watson, getting a good idea of both programming and machine learning at once, what machine learning is and isn't capable of, and then getting to the custom math is another great way.
So what advice would you give to someone who's looking to get into a career in AI?
Yeah, absolutely. I had a bit of an unusual route becoming a data scientist or an AI specialist myself. I have a background in psychology, so when I was studying, I was basically thinking of continuing to do academic research and not go into industry. But at some point in time, I had a realization that I didn't really want to become a professor. I didn't really want to teach or do research in an academic setting. So I started looking for jobs, and it was quite difficult because what we see today is, sometimes what you learn in university doesn't translate directly into what companies want. So how do you bridge that gap exactly? For me, when I was at the time still in Tokyo, Japan, I didn't have a lot of resources around me, well, English-speaking resources at the time, where I could develop my skills. So I looked towards online courses, and online courses helped me, practice Python, practice R, my data analysis skills through programming, and I was able to develop a foundation in the skill set that was highly sought after by many different companies. And then from there, the question became, okay, now I have these skills, these newly developed skills through these courses that I've taken online. How do I translate that to something that I can show and demonstrate to potential employers? So then the next problem I had to deal with was, well, how do I demonstrate that some way? So I created a portfolio of different online assignments, exercises, projects to demonstrate that I could do, the kinds of things that they were hoping that I could do to show my competency. I also, when I came back to Toronto, Canada, I started doing meetups to teach at these meetups, teach R, teach Python, teach data science, to, again, further demonstrate my competency so that people could really see that I could do what I was claiming that I could do, which was a little bit difficult because people would just look at my resume and just see, oh, you have a background in psychology. What does that have to do with, data science or AI? So it was hard in that sense. That I had to overcome that burden of proof. And the final piece of advice that I would give is connect with fellow local AI specialists. So whether they're data scientists, a specialist in a particular field of AI, machine learning researchers, data engineers, just to get a better sense of what kind of AI specialists you might be interested in becoming. Because today there's so many different kinds of AI specialists. You could be very technical. You could be doing research on the latest state-of-the-art algorithms. Or you could be doing something a bit more business-oriented, like trying to optimize revenue, maybe some reporting as well, trying to find ways to personalize a particular service to each and every kind of user that you might have. There's different aspects of AI, and I think it's really important to have some clarity into what kind of role and what kind of job you want. And the first step to do that is to be able to reach out and ask questions to people who are already in the field. And it's a great way to get a sense and also maybe even form some connections that might be meaningful in your career as well. So those are the 4 things. Number 1 is, acquire skills wherever you can. Always be open to learning new things and new skills. Number 2 is demonstrate your capabilities through projects, exercises, something that you can share online, even blog posts and articles. Number 3, if you can, teach at meetups or maybe even more ideally conferences so you can demonstrate your competencies in public. And then number 4 is going to be try to connect with local experts or local specialists who are already in the field so you can get a better sense of what that career kind of roadmap might look like for you.